Consider a continuous stream of matter or particles moving at a velocity u and impacting on an object of mass m that is moving with a velocity v, as shown on the left-hand diagram. The mass of the particles that impact the object during a time delta t is delta m, and these particles stick to the object, increasing its mass by delta m during the time delta t. At time t, we take our system to be the object, including all the matter that impacted and stuck to the object prior to the time t, plus the mass of the particles which will stick to the object between times t and t plus delta t. In other words, the delta m. We assume that the system is not isolated. In other words, we assume that there is a net external force acting on it. And we've called that on the diagram F net ext. Also, during the time delta t, the velocity of the object changes from v to v plus delta v, as shown on the diagram on the right-hand side. The initial momentum of the system at time t is pi, which is equal to mv plus delta mu. So that's the mass of the object times its velocity, plus the mass of the particles that will stick to the object times the velocity of those particles u. The final momentum of the system at a time t plus delta t is given by pf, which is now the total mass, that's m plus delta m, times the new velocity, which is v plus delta v. So therefore, the change in the momentum of the system is just delta p, which is equal to m plus delta m times v plus delta v minus m times v plus delta m times u. Okay, multiplying those brackets out and simplifying, we end up with m times delta v plus delta m times v minus u plus delta m times delta v. Now that last term, delta m times delta v, is the product of two very small quantities, so we can effectively neglect that in comparison with the other terms. It's effectively very small. Okay, neglecting the term delta m delta v, and now dividing the equation through by delta t, and then letting delta t tend to 0, then we will get that the rate of change of momentum with time is just equal to the mass of the object times the rate of change of its velocity with time, plus dm by dt times v minus u. But remember that the rate of change of momentum with time, dp by dt, is also equal to the net external force. So therefore, the net external force is equal to m dv by dt plus dm by dt times v minus u. Right, swapping over v and u changes the sign from a plus to a minus, so we get m dv by dt minus dm by dt u minus v. Now, u minus v is the relative velocity of the mass of particles, delta m, relative to the object m. In other words, the velocity of delta m in the frame of reference of the object. So therefore, we can just write that m dv by dt is equal to the net external force, acting on the system, plus dm by dt times the relative velocity, v_rel, where v_rel is just equal to u minus v. The m dv by dt on the left-hand side of the equation is just equal to the force acting on the object m.